exercise 6C, question number 7. Okay, and we have to solve it using cross multiplication method. Cross multiplication method. Okay, so again observe carefully how to do this. So basically we have to write the given equations first of all. So we have 4x minus 3y equal to 0, right? And 2x plus 3y is equal to 18. Okay, we have to first of all make sure that the constant term is on the left hand side. That means all the terms are on the same side. Okay, that is the first requirement. Now there is no constant term in the first equation. That means what is the constant term? There is no constant term in first equation. That means what is the constant term? 0. Okay, don't panic. Array, there is no C1, there is no C1. There is, in fact, it is 0. Okay, so now what we will do, we will make sure that we have 4x minus 3y minus 0 plus 0 or minus 0 doesn't matter is equal to 0. Okay, just to make sure. And we have 2x plus 3y minus 18 equal to 0. Okay. All right then. So if you have this, then we will say comparing a1x plus b1y plus c1 is equal to 0 with 4x minus 3y plus 0 equal to 0 and a2x plus b2y plus c2 is equal to 0 with 2x plus 3y minus 18 is equal to 0. Okay, we get, what do we get? So we have to write down, right? We start with what? We start with B, then we go to C, then we go to A, and again we go back to B. But so like B, C, A, B. Okay, so we'll write B1, C1, A1, B1. Exactly below that, we have to write B2, C2, A2, B2 is equal to. Now, what is B1? Can you tell me? B1 is minus 3. What is C1? There is nothing. That means 0. What is A1? 4. And what is again B1? Minus 3. Similarly, what is B2? 3. Right? What is C2? What is C2? Minus 18. What is A2? 2. And again, you have 3. Okay, so this is how you have to write down. Now, what do you write? Below. Therefore, x upon, okay, below x, you don't take the coefficients of x. Okay, you don't take the coefficients of x. So, what do you multiply? You multiply these two. So, we have b1 into c2 minus b2 into c1 is equal to y upon. Below y, you don't take the coefficients of y. So, what do you take? You get c1 a2 minus c2a1, and finally you write 1 upon. Here you don't take the constant term, right? So basically you multiply the coefficients of x and y. So we have a1 b2 minus a2 b1. Got it, everyone? At least till here?
Yes, sir.
Okay.
Yes, sir.
Now what you have to do, you have to just substitute the values. So write down x upon b1 c2. So what is b1? Minus 3 into minus 18. b1 c2 is minus 3 into minus 18. Please put the brackets, that is very important. Minus 3 into 0. 3 into 0 is equal to y upon c1a2 minus a2 c2a1. So what do you get? Tell me. 0 into 2 minus 18 into 4. Minus 18 into 4 is equal to 1 upon finally a1 b2, so that means 4 into 3 minus 2 into minus 3. Now when you simplify, you get x upon 18 threes are both are minus, so it will become plus. 18 threes are 54, and this is minus, so 3 into 0 is 0, minus 0 is nothing, so you can simply write 54 minus 0, right? Or you can write 54 itself. So y upon 0 into 2 is 0, minus 18 fours are 72, but it will be positive, right? So 0 plus 72. And finally you get 4 threes are 12, and this minus minus this product will become positive. 2 threes are 6, so 12 plus 6 will be 18. Correct? So in fact, I'll write down here because I have a little space. So you have x upon 54 is equal to y upon 72 is equal to 1 upon 18, right? So what do you take now? To find x, you take the these two parts, x upon 54. So you will say, therefore, x upon 54 is equal to 1 upon 18. Okay, this implies x is equal to 54 upon 18. Therefore, x is equal to 3. X will be 3. Similarly, okay, you can write y upon 72. Okay, now you take these two parts. Okay, which two parts? These two, this and this, right? So you get y upon 72 is equal to 1 upon 18. So if you cross multiply, what do you get?
Y is equals to 4.
72 upon 18. This means y is equal to 4. So finally, you get answer, or the solution is x is equal to 3, y is equal to 4. That's all. Okay, all right. So the given equations are root 2x minus root 3y is equal to 0 and root 5x plus root 2y is equal to 0. Correct? You have to use cross multiplication method to find the values of x and y. That is, we have to solve them simultaneously. Correct? Here again, if you notice, there is no constant term. Okay, that means the constant term is 0. Okay, so in fact, the equations are root 2x minus root 3y plus 0 equal to 0 and root 5x plus root 2y plus 0 equal to 0. Okay. Now you say comparing one by one. Okay, comparing with the standard form, comparing a1x plus b1y plus c1 equal to 0 with root 2x, this one, first equation. Okay, root 2x minus root 3y plus 0 equal to 0 and a2x plus b2y plus c2 equal to 0 with root 5x plus root 2y plus 0 equal to 0. Okay. Now what do you say? We get. What do we get here? So we have, right, again I'm writing it here. We start with B, we come to C, then we again come to A, right? And again we go back to B. So B, C, A, B, that is the sequence. So we'll write B1, C1, A1, B1 equal to, below that, exactly below that, we have B2, C2, A2, B2. Now tell me, what is B1? B1 is minus root 3. Okay. What is C1? 0. There is nothing. I mean, the constant term is not there. That means it is 0, right? What is A1? So root 2. And again, minus root 3. Similarly, what is B2? Root 2. What is C2? 0. Okay. What is A2? Root 5. And again, back to root 2. So here, we have to write the equations like this. Now, x upon, so again I'm telling you, for x you don't take the coefficients of x. So what do you multiply? You multiply with this. So you have b1 into c2 minus minus b2 into c1. Okay, minus b2 into c1. Got it? समजलंय एवढं सगळ्यांना?
Yes, sir.
Yes, sir.
Yes, sir.
Great. So is equal to y upon, again, if you take y, you don't take the coefficients of y. So you take these multiplication. Okay. You take C1 into A2 minus C2 into A1 is equal to 1 upon. You have to write 1 upon. So finally, 1 upon you don't take the constants, right? So what do you take? You take these two, right? So you have A1 B2 minus A2 B1. A1 B2 minus A2 B1. Okay. Now our job is to substitute the values. Okay. So we get x upon, tell me, B1 C2. So what is B1 C2? Minus root 3 into 0 and root 2 into 0. Correct? So minus root 3 into 0 into, oh sorry, minus root 2 into 0. This is going to be absurd. How is it going to be absurd? Denominator is coming 0 is equal to y upon C1 A2. So 0 into root 2 minus 0 into root 5. And finally you have 1 upon what? Root 2 into root 2 minus root 5 into minus root 3. So if you check it clearly, you will notice that these equations cannot be solved. I'll tell you. Okay, don't panic. See, this is x upon 0. Do you think division by 0 is allowed in mathematics? No.
No, sir.
Division by 0 is not allowed. Even 0 upon 0 is not defined. Okay, it is not equal to 1. 0 0 cancel ke liye 1 allowed. It's not like that. 0 upon 0 or any number, any integer on the top divided by 0 is not defined. That means if the denominator is 0, don't worry about the numerator. It is not defined. I'll tell you the significance of this question. Okay, so let us solve this further. So basically you get x upon 0 is equal to y upon 0 is equal to 1 upon 2. Root 2 into root 2 is 2 and this will be plus root 15. Okay. So if x upon 0 is 1 upon 2 plus root 15, correct? That means if you take these two, what do you get? You get x is equal to 0 upon 2 plus root 15, right? That means x is equal to 0. Similarly, y is going to be also 0. But is it correct? Is it correct to say x
No,
is 0
sir.
and y is 0? Do you think?
No, sir.
No. Then what is the solution of this? Please try to understand. These two lines, okay, these two lines have no solution. What do you mean by that? See, when do you have solution of two lines? When they intersect. Okay, when two lines, see, this is one line. These are linear equations in two variables. So basically, this equation represents a straight line. You have drawn a straight line on a graph, right? So let us say when there is solution, for example, last time we had a unique solution 3, 4. What do you mean you have a unique solution? That means the point of intersection, this is the point of intersection. These two are the lines, okay? This is one line, this is another line. These two lines intersect at a point and that point is x comma y, which is the common point of those two lines. That means it is the solution of these two lines. That means it is the point of intersection of these two lines. That means they have a unique solution. But here there is no solution. So what does this mean? याचा अर्थ काय होतो? What do you infer from this? What do you infer? X is equal to 0 and y is equal to 0 is the solution or there is no solution? Now the question is x is equal to 0 हे solution है, y is equal to 0 हे solution है का त्याला solutionच नाहीये. What do you think?
No solution.
No solution. Are you sure?
Yes, sir.
Okay. Anyone? Kunal, also, anybody feels that the solution is x is equal to 0 and y is equal to 0. That means these two lines intersect at the origin. असं कोणाला वाटतंय का? Is it the possibility? म्हणजे हा x
Yes,
axis
sir.
आहे, हा y axis आहे, and this is line L1, let's say represented by this, and this is line L2, let's say represented by this. Okay, and they
Sir,
both
they itself are plotted on the origin.
and they both intersect at the origin. Is that the way we should interpret, or we should interpret that there is no solution? What do you think?
Sir, we can use 0, 0, 0, comma 0.
Are you sure?
Yes, sir.
Yes, very good. Okay, so please pay attention. Okay, please once more pay attention. I'll come back to there is a thing which we'll do afterwards. When there is a solution, when there is a unique solution, when there is infinite solution. That is also I'm going to tell you. That is not in the syllabus, but still I want to cover it because you should know. Basically, solving means what? Okay, what we are solving, we are basically trying to find the point of intersection of these two lines. These are lines, graphs आहेत हे, बाकी काही नाही आहे. And we are trying to find the solution x comma y. That means we have to try to find the point of intersection. Okay, so in fact x upon 0 is not defined. Yeah, we know that, but x upon 0 is 1 upon 2 plus root 15. That means x is 0. Okay, that means x is 0 and also y is 0. So basically the solution is x is 0, y is 0 and y is 0. Okay, in fact these two lines have a solution which is the origin. This is what we can conclude. So please pay attention. Okay, the heading is physical significance of the solution to simultaneous linear equations, in two variables, Okay, so what is the physical significance? Number one, okay, we find the solution. What does that mean? It means that, okay, I'll make a table so that it will be clear to you. Just pay attention and then you can write down. Okay, so I'll make a table here. So this is the serial number. Then I will write down the equations, the criteria, okay, the physical significance, and the diagram also. Okay, bar. All right, so I'll make three parts here because we have three types of solutions. So first of all, we have a serial number 1, 2, 3. Here we have equations, okay, and we'll write one example. Then we have condition. Then here we have a graph, and here basically we have a type of solution. Okay, type of solution. So please pay attention. So when we find out the solution, okay, we find out the solution. Let's say x is equal to 2, y is equal to 4. What does that mean? That means you solve these linear equations. That means you graph those. You can graph a line, right? You can take any 3 points, okay, plot them on a graph paper. You can draw the line. Okay, why 3 points? Because any two given points are always collinear. So if you take the third point, that makes it sure that it passes through the third point also. So basically, let us say if you have equation a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, that means what is the condition for type of solution? Type of solution is like unique solution. What does this mean unique solution? म्हणजे आतापर्यंत आपण करत आलो ते. That means x has a fixed value, y also has a corresponding fixed value. Okay, you cannot change that. And the graph looks like this. So this is line L1. Oh, एक minute. This is line L1 and this is line L2. This is line L2. So basically this point is x comma y, which is the solution. That is the solution. So this is line L1, this is line L2, or whatever, you know. So this is line L1, this is line L2, which are represented. So what is the uniqueness about this? What is the condition for this? The condition is that A1 upon A2 not equal to B1 upon B2, not equal to C1 upon C2. They are not equal. Okay, हा जो रेशियो आहे ना A1 upon A2, B1 upon B2, C1 upon C2, that is never equal. त्याला आपण म्हणतो युनिक सोल्युशन. Okay, what does this mean? This means that lines are intersecting. Okay, I'll write it again. Lines are intersecting. So have you got this point? समजले सगळ्यांना काय कंडिशन आहे ते? Is that clear?
Yes, sir.
Yes, sir.
Okay. Okay, I'll again repeat it. So second मध्ये काय होणार आहे? The type of solution here is, you know, infinitely many solutions. This can happen. I told you in the beginning, infinitely many solutions. Infinitely many solutions म्हणजे काय? That means the lines are overlapping. One line is on the other line. Okay, that means lines are overlapping. They are on top, or you can say coincident. Not overlapping is not a good word. The lines are coincident. They lie on top of each other. I'll draw the diagram so that you will understand. So let us say I take this color. So this is, whatever may be the orientation, we don't care. I'll draw a different line, different color. I'll just draw it just for the sake. I'll draw it short. See, lines are indefinitely extended on both the sides. So you cannot really measure the length of line. So let's say this is line L1, this is line L2. They are overlapping, they are on top of each other, coincident. So how are the equations look like? Equations कसे दिसतील? The equations are very interesting to note that they have A1, okay, A1 x plus B1 y, okay, plus C1 is equal to 0. Now, if they have infinitely many solutions, that means, the equations are same. In fact, the second equation will be A2x plus B2y plus C2 is equal to 0. In fact, A2 will be a multiplier of A1. Similarly, B2 will be a multiplier of B1 and C2 will be a multiplier of C1. Okay. So in fact, we have A1 upon A2, okay, is equal to B1 upon B2, okay, is equal to C1 upon C2. म्हणजे काय की हे एक कॉन्स्टंट आहे, लक्षात घ्या. ह्याचा जो रेशियो आहे ना हा इथे इक्वल नव्हता. Okay, here the ratio is equal. A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2, which is a constant. Then only you have infinitely many solutions. And the last thing we have A1x plus B1y plus C1 is equal to 0. A2x plus B2y plus C2 is equal to 0. In fact, here A1 is equal to A2, B1 is equal to B2, but C1 not equal to C2. So what is the condition? They are very similar, but you'll understand. So the condition is, in fact, A1 upon A2 is equal to B1 upon B2. Okay, their ratio is same, but the constant is different. I'll give you example so you'll understand. The constant is different. So not equal to C1 upon C2. Okay, here there is no solution. There is no solution. So what do you mean by that? There is no solution म्हणजे काय? The lines are parallel. The lines are parallel. Do you think the parallel lines ever intersect? No, never. The lines which are in the same plane and which are non-intersecting, they are called parallel lines. So what do you mean by this? We can draw a diagram like this. One line is like this, and the second one is parallel to this. Okay, so is that clear? L1, L2. So these are what? Parallel lines. Is that clear? Got it?
Yes, sir.
Right? So let me quickly give one example in the red color, you will understand. Okay, first question, it is very easy. I can just say, let's say 3x plus 2y plus 5 is equal to 0. Let's say 7x plus 5y plus 11 is equal to 0. Take any numbers. Okay, never the ratio. Baga na, 3 upon 7 is not equal to 2 upon 5 is not equal to 5 upon 11. It is not going to be equal. Okay, so that is the example. Here, how will you give the example? It's very interesting. Okay, I'll write the example here, for example. So let's say we have 2x plus 3y plus 7 is equal to 0. The second equation will be exact multiplication of this. Let's say we multiply this equation by 3. What do you get? The second equation will be 6x plus 9y plus 21 is equal to 0. Although the equations look different, although the numbers look different, if you take the ratio, 2 upon 6 is 1 upon 3. 3 upon 9 is also 1 upon 3, and 7 upon 21 is also 1 upon 3. That is why I said these are parallel lines. Do you understand now? Clear?
Sir, coincident lines.
Sorry, parallel line, coincident lines. Yes, coincident lines. And finally, here I'll take the exact equation 2x plus 3y plus 7 equal to 0. I'll take another also 6x plus 9y. Instead of 21, I'll take, let's say, something else. Let's say minus 12. Who knows? Anything but which will break this. So a1 upon a2 is 1 upon 3. b1 upon b2 is also 1 upon 3. But c1 upon c2 is something else. And hence, these are called as parallel lines. Okay, they will never intersect. And hence, there is no solution. Okay, so I think you should note this. So these are the equations which do not appear to be linear equations in two variables. The reason is that, let me tell you. See, when you say it is an equation in variable x or y or other variables, the variable should not have, okay, what I'm saying, the variable should not have a degree of a fraction because it should be linear, it should be always one. It should not be negative also. Okay, negative 1 means x raised to minus 1 means 1 upon x. Y raised to minus 1 means 1 upon y. So if you observe these equations closely, what do you think? This is nothing but 7 into x raised to minus 1 plus 8 into y raised to minus 1 is equal to 2. Similarly, this equation will be 2 into x raised to minus 1 plus 13 into y raised to minus 1 is equal to 22. Correct? So in fact, if you notice this, we have minus 1 as the coefficient. Is that correct? Is that correct? No.
No, sir.
So these are not linear equations in two variables. These are not according to the definition. So these are the equations which need some manipulation, okay, which need some extra steps. So what are those steps? That is what we are going to study. So these type of equations which do not appear to be linear equations in two variables are called equations reducible. This word is very important. Reducible. That means we can convert these equations in the linear equations in two variables form. Do you understand what I mean? Right? So let me go to the alternate method. That is what I suggest you to follow always. Okay, it's very easy. In fact, what we will do. Okay, all right. So what we will do, we will say, let me go to the whiteboard and solve it for you. So let us. Okay, don't write anything right now. I'll solve this equations reducible to linear equations. Okay, all right. So what are the equations given to us? We have been given 7 upon x plus 8 upon y is equal to 2. Okay, and then we have been given 2 upon x plus 13 upon y is equal to 22. Okay, 13 upon y is equal to 22. Okay, let us not write this 1 and 2 here. So here what I'm going to do is, pay attention. Okay, this is nothing but 7 into 1 upon x, right? So what is 7 upon x? 7 into 1 upon x. What is 8 upon y? 8 into 1 upon y is equal to 2. And what is this? This is 2 into 1 upon x plus 13 into 1 upon y is equal to 22. Now what I'm going to say is, let 1 upon x be p, or you can take a. Don't take x and y because they are already there. Take any other variable apart from x and y. So I'll say let 1 upon x be p and 1 upon y be q. So in place of 1 upon x, I'm going to call it as p, and instead of 1 upon y, I'm going to call it as q. Okay, so what do you get in fact? Therefore, the equations become, what do they become? Bola. 7p plus 8q is equal to 2. This is equation 1. Secondly, this becomes 2p plus 13q is equal to 22. This is equation 2. Now, you are free to choose any of the 3 methods learned previously. So you can use elimination by substitution, you can use elimination by equating the coefficient, okay, or you can use cross multiplication method also. It's up to you what you want to use. You tell me what you want to use to find the values of p and q. Which method would you like to use?
Cross
Cross
multiplication.
Cross
multiplication.
multiplication. ठीक है, all right. Let us use that. So basically, we have 7p plus 8q minus 2 is equal to 0. Follow that. This is very important. You have to take the constant to the left hand side. I mean all the terms on the one side. So you have 2p plus 13q minus 22 equal to 0. Okay, so we will write comparing a1x plus b1y plus c1 equal to 0. Okay, with 7p plus 8q minus 2 equal to 0, and a2x plus b2y plus c2 is equal to 0, with 2p plus 13q minus 22 is equal to 0. Okay, so now we have a, x and y is so synonymous, so you should avoid that. Here you have to write p and q, that's all. Okay, just write p and q. We don't have x and y, we will find x and y afterwards. Anyways, so we get, so again I'll draw a circle. We start with b, we go to c, then again we go to a, and again we go back to b. So we have b1, c1, a1, b1. Immediately below that b2, c2, a2, c2 is equal to, what is b1? 8. c1 minus 2. Again 7, again 8. Similarly, 13 minus 22 to 13. Is that clear? Got it, everyone? At least here, till here. Okay, now we will write the equation. Let me go to the next page. So we have x upon, so when we have x, we multiply this. Okay, b1 c2 minus b2 c1. So we have b1 c2 minus b2 c1 is equal to y upon. So when we have y, we multiply these two. So c1 a2 minus a2 c1 is equal to 1 upon. So when we have 1, we multiply the coefficients of x and y. So we have a1, oh wait a minute, I have written.
Sir, y upon a1 c2 minus c2 a1.
Yeah, here we have b2, I have written c2.
Sir, in y also it is c1 a2 minus c2 a1.
Yeah, c2 a1, yeah. Yes, c2 a1. And here we have a1 b2 minus a2 b1. a1 b2 minus a2 b1. Correct? Now substitute the values of what is b1. So here 8 into minus 22. So we have x upon 8 into minus 22 minus 13 into minus 2. Minus 13 into minus 2 is equal to y upon y upon what? 2 into 2 minus 2 into 2, right? Minus 2 into 2 minus 22 into 7. Is that correct? Is equal to 1 upon 7 into 13 minus 2 into 18, right? Correct. So what do you get? X upon 22 8 is how much?
Minus 176.
Yes, minus 176 minus plus 26 is equal to y upon minus 4 plus 22 into 7 is 154.
154.
Correct. Is equal to 1 upon 13 sevens are
51.
91 minus 18 twos are 36. Okay. So we have x upon minus 150 is equal to y upon 150 is equal to 1 upon what is 91 minus 36? What is 91 minus
55.
Is it 55?
Yes, sir.
Yes. So we have x upon minus 150 is equal to 1 upon 55. Therefore, x is equal to minus 150 upon 55, right? So if you divide by 5, you get 11 and you get how much?
Minus 30.
Minus 30.
Minus 30. So x will be minus 30 upon 11. Now you tell me, what was x?
P.
1 upon p. No, 1 upon x was p. So that means, okay, that means 1 upon p will be x, right? Is that clear? So p will be reciprocal of x, right? Am I correct?
1 upon.
Correct. Sorry, I should have written as 1 upon x is p. So p will be 1 upon minus 30 upon 11. That means minus 11 upon 30. Is that correct?
Yes, sir.
Right. Okay, but I think it's very odd. We have missed something. Wait a minute. Sorry, this is not 18. Just we have to make one change. This is actually 8. So 91 minus 16 will be 75. Yeah, 75. So that was the only change. And now it's going to be really easy. Okay. What the change? So we have 1 upon 75. So x will be minus 50 upon 75. That means x will be
Minus half.
minus 2, right? X will be minus 2. So if x is minus 2, but as 1 upon x is p, okay, again I have made a simple thing that x is not, this is not x, this should be p and q. Again, see, we are so obsessed with these letters that this is not x. In fact, these are the p and q we have. P, q, p, q. So this is what you have to make sure that you use the right letter. So p is minus 2, but as x is 1 upon x is p, that means x will be 1 upon p, that is 1 upon minus 2, or x is minus 1 upon 2. Similarly, Q will be 150. Okay, I'll write one more step. As Q upon 150 is equal to 1 upon 75. Therefore, Q will be 150 upon 75. That means Q will be 2. Okay, so here Q is 2. We don't want Q, we want Y. So we can write as 1 upon Y is Q. We have substituted that. Therefore, right, y will be 1 upon q. So y will be 1 upon 2. So this is the solution. So x is minus 1 upon 2 and y is 1 upon 2. That is the solution. Okay. So let us take the same equations and let us not use that substitution method, and let's see how we can find the solution. Okay, let me write the equations again. So we have basically 7 upon x plus 8 upon y is equal to 2. Okay, let's say we don't want to use the substitution method. Then there is there are two ways. In fact, there is only one way which is suitable, which is nothing but equating the coefficient method. Okay, so let us say I find the coefficients of x, rather coefficients of 1 upon x being simpler. Okay, they are small numbers compared to the coefficients of 1 upon y. So what we will try to do here is we will say multiply equation 1 by 2 to get, what do we get if you multiply equation 1 by 2? 14 upon x plus 16 upon y is equal to 4. Let us call this equation 3. And multiply equation 2 by 7. Okay, what do? We multiply equation 2 by 7 to get, you get 14 upon x plus 13 into 7. How much is 13 into 7? 91 upon y is equal to 154. Okay, now you can see that we can eliminate 1 upon x. How? By subtracting the two equations. Okay, so we'll say subtracting equation 4 from equation 3 to get. Okay, so 14 upon x plus 16 upon y is equal to 4, equation 3. When you subtract, so you get 14 upon x again plus 91 upon y is equal to 154. Okay, or you can subtract equation 3 from 4. It's up to you, whatever you want to do. So when you subtract, all signs will change. Okay, all are positive signs, those will become minus. In fact, we can get rid of 1 upon x. Okay, that was the aim. So here 16 upon y minus 91 upon y. So what is the answer? Denominator is same. Y is the denominator. Don't panic. You don't have to find LCM or anything like that. Don't worry. What do you get? Minus 75, right? Minus 75 upon y is equal to minus 150, right? So when you cross multiply, y will go here, right? So you get y will be minus 75 upon minus 150. This implies, okay, this implies y will be 1 upon 2. Simple, as easy as that. So you get directly the value of y. You don't have to worry. Are you getting my point, everyone? Is that clear? Now you have to use this value of y in either equation 1 or 2. You tell me in which equation you would like to use it. 1 or 2?
1.
Yeah, 1. So put y is equal to 1 upon 2 in equation 1 to get. So what do we get? We get 7 upon x plus 8 upon 1 upon 2 is equal to 2. So 8 upon 1 upon 2 is nothing but 16. So this implies 7 upon x plus 16 is equal to 2. So this implies 7 upon x is equal to 2 minus 16. Therefore, you get 7 upon x is equal to minus 14. Therefore, when you cross multiply, you get x is equal to 7 upon minus 14. That is minus 1 upon 2. Never keep the negative sign in the denominator. 7 ones are 7 twos are. So x will be minus 1 upon 2 as the solution. So this is the solution which you can get directly by using the method called elimination by equating the coefficients. Here we don't have to substitute like P and Q or A and B for 1 upon x and 1 upon y. This is the direct method. Okay, this is also correct.